Welcome, dear friends. Today we're going to review some cutting-edge AI tech that's shaping up to be a real game changer. Generative AI models. We're talking about AI systems that can literally generate brand new content from scratch. Images, videos, audio, text, you name it. Wild, right? This isn't just incremental progress. Generative AI represents a profound shift in how we create and interact with media and information. With the right model, architecture, and some clever math under the hood, we can now conjure up virtually anything in the digital realm by simply describing it in natural language. It sounds like pure science fiction, but it's very much real and happening right now. So let's dive in and understand what's actually going on with this generative AI wizardry. How do these models pull off their magic tricks? What are the key concepts and techniques involved? And what kind of use cases and applications are unlocked by having creative machines at our beck and call? At the heart of modern generative AI models are deep learning architectures like variational autoencoders, generative adversarial networks, transformer language models, and diffusion probabilistic models. Despite their fancy names, the core idea is shockingly simple. Train a neural network to capture the underlying patterns in a massive data set of examples, and then leverage that learned knowledge to synthesize brand new samples from scratch. It's a bit like teaching the model an entire language by showing it tons of example sentences, paragraphs, and books. Once it deeply understands the rules of grammar, syntax, semantics, and so on, the model can then compose its own totally new, yet fluent sentences and passages from scratch. Now, think about expanding that generative capability beyond just text to images, videos, audio, 3D models, essentially any kind of data modality. That's the true power of these latest generative AI techniques. They can learn the languages and patterns underlying different content formats and generate novel, coherent samples across all those domains. Okay, so those are the big picture ambitions of generative AI. But how is it actually achieved under the hood? What are the key technical concepts we need to wrap our brains around? Well, first up, we have representation learning, a core machine learning principle where we automatically derive rich, transferable data representations instead of hand engineering input features like we did in the old days. These learned representations encode all the important patterns and knowledge that the model needs to generate realistic samples. Techniques like contrastive learning and self-supervised learning on huge data sets allow us to pre-train incredibly powerful representation models. Next, we leverage probabilistic reasoning and modeling to quantify the underlying uncertainty and likelihood of different possible outputs. Generative AI models essentially learn the probability distributions over the data they're trained on, so they can then sample realistic new instances from those high-dimensional distributions. Optimization is another key piece of the puzzle. We need highly efficient algorithms like stochastic gradient descent to tweak the model weights in just the right ways to minimize whichever cost function we care about, be it pixel-wise reconstruction, error for images, or cross-entropy, loss for text. Optimizing these extremely high-capacity neural nets is an immense computational challenge. And finally, we have tools and frameworks like adversarial training that let us build AI systems that competitively push each other towards better and better performance. Think of a generator network trying to produce synthetic data samples to fool a discriminator network. All right, with the core technical principles covered, let's talk use cases and applications, because this is where generative AI really shines and starts feeling like the future arrived early. With this constant back and forth driving both players to improve over time. Combining all these elements allows us to craft generative models that can capture stunningly complex data distributions. With the core technical principles covered, let's talk use cases and applications, because this is where generative AI really shines and starts feeling like the future arrived early. We're seeing an explosion of creative AI tools that empower anyone to generate novel content just by describing what they want in natural language. Photorealistic imagery, music, animations, 3D models, and more. You can literally spawn wholly new visual worlds and artistic media into existence with these generative AI models. But it goes way beyond just artistic and creative use cases. Generative AI is a powerful engine for synthetic data creation, which is immensely valuable for everything from training AI systems safely to scientific simulations. We can generate on-demand data sets of examples that would be impossibly difficult or dangerous to collect in the real world. In the software world, large language models pushing the boundaries of text generation are streamlining programming by auto-completing code, documentation, scripts, and more, just based on short natural language prompts. The potential to massively boost developer productivity is staggering. There are mind-bending applications in fields like drug discovery too, where we can iteratively design and optimize novel molecular structures with desirable properties by navigating the incredibly complex space of chemical compositions using generative models. Look, I could honestly ramble for hours about all the different mind-blowing generative AI projects happening across academia and industry. The bottom line is, if you want to be working at the cutting edge of AI capabilities in 2024 and beyond, you need to go all in on mastering the tools and techniques of modern generative modeling. Build a strong foundation with deep learning, probabilistic modeling, optimization theory, and data processing skills. Get hands-on coding experience with frameworks like PyTorch, TensorFlow, and JAX for defining and training neural network architectures. Study up on the latest model innovations coming out of places like OpenAI, DeepMind, Google Brain, and others. And most importantly, experiment, tinker, and push these generative AI systems to their limits through personal projects and challenges. There's still so much uncharted territory left to explore as we unlock the full potential of machines that can generate essentially anything. So what are you waiting for? Let's go build the wildest generative AI tools the world has ever seen.